Okay, in our second and final video on functions, we're going to start off with looking at composite functions. Composite functions is like a function of a function. Okay, so here we have our domain of f. Okay, domain of our f function. So we put 1, 3, and 5 into our function called f, and we get out 4. We put in 3 and we get out 6. We put in 5 and we get out 8. And now after we get in this range, this 4, 6, and 8, we then put it into our other function g. Okay, and we get 11. We put 6 into function g and we get 15. We put 8 into function g and we get 19. Okay, so basically we're putting it into one function, and then we put our answer or our range of the first function into our second function. Right, so basically the range, the number that's spat out on our first function, is actually the domain or the number that's put into our second function. And how we say that is we say f o g. It's basically f of g. Okay, if f is the first function, g is the second function. We can also just say f g. Okay. So how do we do that? Well, let's look at this question here. So we have a first function f of x, which is x plus 3, and we have our second function g of x, which is x squared minus 1. First one, we want to find out what f of g is. So what we do is, f of g 2. So here's what we do first. We get g of 2. So basically, the function that's nearest the number, we find that first. Okay, that's the only mistake you'll make here. So we want to find out what g of 2 is. So the first step is find out what g of 2 is. So we put 2 in for x, and we'll get 2 squared minus 1, which is 3. Okay, so there is the number that's spat out for g. And now we put that 3 into our fx. Okay, so we put the g then, we put the 3 into fx. So x plus 3, we put the 3 in here, we get 3 plus 3, we get 6. Okay, so the answer to this is 6. Okay, next one. Okay, so this is g of f. Right, so, and I'll rewrite this actually. This can be gf or it can be g of f minus 1. Remember though, it's this one we do first. Okay, it's the one nearest the number. If they don't give you a number, remember it's this one first, so it's the second one first. Okay, so this time we put minus 1 in for x. Okay, in this f of x function. So f minus 1 equals minus 1 plus 3, which equals 2. Then we take the g function, 2 squared minus 1, which is 3. So this one here, 3. Notice f of g is not the same as g of f. You have two different answers. Okay, so it does matter which you put into which function first. Okay, next one. We don't have a number, we just have x, but we'll work it out as normal. So the g, so it's g squared minus 1, that's g of x. And then we'll put that into the f function. So the f function is fx plus 3. Whatever we have here, we'll put it in for that. So it'll be x squared minus 1 plus 3, which will give us x squared and plus 2. Okay, so that's that one. And I'll let you do this one yourself, so if you want to pause and do that. Okay, the next thing we're going to look at is just taking a function and then doing something to the function and seeing how it moves. So for example, here is a function fx equals x squared, and that function when sketched looks like this. But what if then I added 2 to that function? So look, so I have fx squared, and I plus the 2 over here. Okay, so add a 2 onto the function, so that would be, so fx would then equal x squared plus 2. What would happen? Well, if I add 2 outside the x, okay, so look, notice that this 2 is being added outside of that x bracket. Well, if we add 2, it'll just move the function up 2. So wherever that function is, wherever that blue line is, it'll just shift the whole thing up 2. If we look at this one here, fx minus 3, notice the minus 3 is outside the bracket, so that will move it down 3. Okay, so the blue line, the blue curve will be moved down 3. Okay. Notice this one now. Okay, so I tidy this all up again. Okay. Right. Notice this. The 2 now is added inside the bracket. Okay, so this will look like this. So this will look fx plus 2. Okay, fx plus 2. Well, that's basically x plus 2 squared. Okay. Notice the other one was x squared plus 2 outside, but this one it's inside the bracket with x. So we'll add the 2 to the x bit. What will that do? Well, if this is the little bit that might confuse you. If you are adding 2, then it pushes the curve back the way. So if you're adding, it pushes it that way. So that is going to be pushed this way 2. So it's going to look like that, maybe pushed that way 2. This one here then, minus 3. So it's going to push it forward 3. So it's going to look like this. Okay, so just be careful. In this one, if it's plus, it's going back the way, and if it's minus, it's going forward. Right? In the one where the number is added to the x. Okay, if we look at this, we have fx, and now we have minus fx. What that will do is it will do an axis of symmetry. So it'll basically do the opposite. Okay, so if fx is the blue line, then minus fx is the red. And lastly then, 2fx. Okay, so I'm going to draw, let's just say I'm going to draw a different curve. The curve I draw is this. Okay. Well, if this curve at this point is say 2 on the y-axis, and if it's here is, let's say, 3. Well, if I put a 2 in front of it, what will happen is this will double. So it'll go up to 4, and this will go down to 6. It'll start at the same place, but I'll just go up to 4 and down to 6. Okay, so it'll increase the range. If I put maybe a 3 in here, then this will go up to 6. 3 times the 2 is 6, and down to 9. 3 times the 3 is 9. And it will just start at the same place. Right. And it will just go up to here, down to here, and back. Okay, so the domain would be the same. The distance from here to here is the same in all 3, but the range is different. And the next thing we're going to look at is just drawing a function when we're given its roots. Okay, so we have a function here. This is it, and we're asked to draw it. Okay. If we multiplied out this function, so the x by the x plus 1 by the x minus 2, we would get x cubed minus x squared minus 2x. Okay, so what we need to know when we're drawing this is, first of all, the shape it's going to be. Is it going to be like this? Is it going to be this, like this, like this, or like this. And the second thing then, the points where it crosses the x-axis, like here, here, or here. If we know that, well, then we could sketch it. We could give it a rough sketch anyway. So if we look at this, here's the roots. Okay. What we do is we let each of the roots equal 0. So x equals 0, x plus 1 equals 0, x plus 2 equals 0. So that will give us, obviously, x equals 0, x equals minus 1, x equals minus 2. These are the points that it crosses the x-axis. What shape is it? Well, look here, it's cubic. There's a plus here, so I know it's going to be that shape. Okay, so I'm going to sketch that. I know it's going to hit at x is 0, so here, x is minus 1, here, and x is minus 2, here. Okay. Actually, sorry, let's kind of change this. Okay, we'll just go back. We'll change this to a minus. Okay, therefore that would be a minus, therefore that would be a plus. Okay. Right, so now we have minus 1. So again, looking at these, minus 1, 0, and 2. And I know the shape of it then, it'll go up, down. So that's the general shape, general sketch of that. Okay, we're going to look now at inverses of functions. Let's say I put in into this function, this fx function, and I'm going to put in a domain of 1, 2, and 3. So I'll put 1 into this, and I get 3 ones minus 1, which is 1. I put 2 into this, 2, 3 or 6 minus 1 is 4. I put 3 into it, and I get 7. Okay, so if I was to draw this function, then I'd have the points 1, 1, 2, 4, and 3, 7. Okay, I'll just sketch that. So 1, 1 would be about here, and 2, 4 would be about here, 3, 7 would be about here. So there's my fx function. Right, if I want to get the inverse of that, then here's what I do. Inverse. Go in red. I first of all take my fx function. I call my fx y, so I say y equals 3x minus 2. And then I rearrange it so I get x over here. So I have 3x equals minus 2 minus y. So I divide by 3 across, and I would get x equals minus 2 minus y over 3. Last thing I do then is I change this I change this x to fx inverse. Okay. And I change the y to x. Okay, so there's the steps I follow. Right? Change it to y first, write it in terms of x, and change the x to the inverse function, and wherever there's a y, put in an x. Here's my inverse function. Now, the nice thing is here, if we look at our function, the original function, when I put in 1, it spat me out 1. If I put in 2, it spat me out 4. And if I put in 3, it spat me out 7. So the domain was these numbers put in, and the range was these numbers. However, in the inverse function, this here, well, if I put in these numbers, if I put in these numbers as the domain, it'll actually spit me out these numbers as the range. Okay, so it's just kind of undoing what was done really to the number. So the last thing we're going to look at then is limits and continuity. We're going to first look at limits. Okay, and this is how we write it. So we have a function, and the function is x squared. And we're looking then at the limit as x approaches 3. So in this function it says the limit of the function x squared as x approaches 3 is 9. And what I mean by that is if I put numbers into this x squared function, the closer that the domain number, the number I put in, is to 3, then the closer the output number is to 9. For example, if I put in 2 into it, I get 4. But if I put in 2.5, I get closer to 9. If I put in 2.9, I get closer to 9 again. And if I put in 3.1, I get closer to 9. Okay, so the closer number I put into 3, I get out 9. And we can see that here. Look, if I put in 3, I get out 9. If I put in 2.5, I get close enough to 9. If I put in 3.5, I get close to 9 again. Okay, so the closer number I put in to 3, it'll spit me out 9. Right, so that's just a normal limit. Let's consider this one then. Okay, so here is my function. Okay, so how do I find the limit of that function when x approaches 2? Well, all I do is I put in 2 into that function, okay, and see what the limit is. So here we go, 3, 2 plus 2 over 2 plus 4, which will give me 6, that's 8, over 6, which will give me 4 over 3. So the closer I get to 2, so the nearer number I put in to the function that's closest to 2, the closer I get to 4 over 3. So if we look here, if I put in 2, I get 4 over 3. If I put in 1.5, I'll be this close to it. If I put in 2.5, I'll be this close to it. The closer number that I put in, the closer the number that I put in is to 2, the closer I get to 4.3. Okay, so generally with these ones, if we're asked for the limit of a function, we just put in that number. Okay, we put in what the limit is, and we'll see what it spits out. Let's consider this one, however. Okay, so this function says find the limit of the function x squared minus 9 over x minus 3 when x approaches 3. So, as I said before, we'll put in 3 into the function. So it's 3 squared minus 9 over 3 minus 3. And that will give me 0 over 0. Now we have a problem. That does not equal 0. And here's why. Anytime we have a 0 as a denominator, I suppose the fraction blows up essentially. Okay? So we can say it's inconclusive. It doesn't matter if we had a number up here, okay, any number. If we have a 0 on the bottom, it's inconclusive. Right. So what do we do? I've sketched it over here. Right? So I've sketched this function over here. So if I put in minus 2 into the function, I get, I think it's 1, right? And if I put in minus 1, I get this. 0, I get that, and that, and that, right? So I'm after putting in numbers, so I know that the function looks something like this. If I put in 3, however, it blows up. If I put in 2.5, I get to here. If I put in 3.5, I get to here. If I put in 4, I get to here. So the function seems to continue. If I put in 2.99, I'll get to here. And 3.1, I get to here. However, I see that there's a bit of a gap here. So it's like, it's essentially like this function will start. Once it gets to 3, it just stops and then goes again. But common sense would say that the function should really just keep going. Okay? There's no real reason why there's a gap at 3. Well, it's just a problem with the maths. If you get something like that, okay, where when you put in the limit, you get a 0 on the bottom, we have to do something. Right? We're going to have to factorize out the numerator and the denominator. Okay, we're going to have to factorize out these. See if there's anything on top and bottom that can cancel, and then try it again. Okay, try to put in the 3. So let's see. Let's try it. So we have x minus 3 in the bottom, and I notice we have an x squared minus 9 on the top, which is the difference of two squares factorizing. So x plus 3 minus 3. These will cancel then. This and this. So I get x plus 3 over 1. Now I can put in my limit, 3. And I get 3 plus 3 over 1. Okay, I put in the 3 here. So I put in this 3 for the x. I get 3 plus 3 is 1, which is 6 over 1, which is 6. So now let's find my point. So 3, and that's 6. So there's my last point that I was missing all along. So in actual fact, it wasn't an empty gap here. Okay, once I factorized it out, I can make sure that my function continues the whole way. So what's the limit of this function as x approaches 3? Well, 6. Okay, but in order to find it, I had to factorize it out. So the easy ones, you'll just be able to put your limit straight into the function and find it out. These ones you may not. You may have to factorize it out and get your number then. Okay? Right, last thing I'm going to do is I'm going to look at continuity. Continuity is if of a function is if there's no gap in a function. So for instance, if I look at this function and I can put my pen on it and there's no gap in it, then I can say it's continuous. However, a function like this with a gap, okay, I can't put my pen on it and draw it all the way, well then that's not continuous. Let's look at this function. I'll highlight it in yellow. So look at this, I can put my pen on it, I can continue it, so it is continuous. Same with this, continuous. Same with this one. I didn't think it was continuous because there was a gap, remember, at 3. But then when I factorized it out, I realized it was. Now, I'm going to tidy this up and we're going to look at this function. Right. If I was to put numbers into this function and plot it, it would look like this graph. Okay, so notice I put numbers. This is -1, by the way. Okay, here, so -1. So let's say I put -4 in, and I get this point. -3, and I get this point. -2, and I get this point. If I put -1 in, let's see what happens. And look, 0 on the bottom and it blows up. Also, I'm not really able to factorize this out. Okay, can't factorize it out really. If I put in, let's go with the next number. So we have -1 there. Let's put in 0. Okay, I get to here, and 1 I get to here, 2 I get to here, 3 I get to here. But at this point, at minus 1, I cannot draw my function. The function will never give me a value when I put in minus 1. That means this function is discontinuous at minus 1. So what happens to this function is it'll come all the way here and it'll go up, 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 and down, 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 down. Sorry, down, 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 down. But it will never hit this point, this line here, minus 1. What will happen then when I go a little bit bigger than minus 1, so let's say minus 0.999, it will start again here and it will go. Right, so this function is discontinuous. Its limit is minus 1. Right, so the function discontinues at minus 1, its limit is minus 1. The closer number I put into minus 1, so closer number I put into minus 1, closer it is to this point, but never reaches it. Okay? Very last thing I do then. This limit of a function, so all along we were looking at limits as, I don't know, x approached 2 or x approached 3, etc. But this is when x approaches infinity. So what I mean by that is, let's say we have a function, and I'm going to draw a function. So let's say this is 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3. Okay. And let's just say when I drew the function it looked like this. Now, notice this function starts out at 0, 0, and it kind of seems to get closer and closer to 2, doesn't it? But it doesn't seem to reach 2. And the further I go this way, the closer it will get to 2. And if I go in this direction, okay, so this direction here, to infinity, so if I keep going there and there and there forever, the closer that this blue line will get to 2. However, it will never ever reach it. Okay? So, how do I find out if I'm given a function like this? How do I find out what number it approaches as it goes to infinity? Just like this one up here, it approaches 2 as I go to infinity, this way, plus infinity. But if I'm given something like this, how do I find out what number it approaches? Well, here's what I do. So step 1 in any of these. Divide numerator and denominator by highest power of x. And then step 2, let all x's equal 0, or in other words, get the limit as x approaches 0. It'll make sense when I do it. Right, so we're looking at this function. The highest power of x, well, highest power of x is just x. So we'll divide everything by that. So we have the limit as x approaches infinity is 4x divided by x is just 4, plus 1 divided by x is 1 over x. 2x divided by x is just 2, plus 3 divided by x is 3 over x. So that's step 1. We've divided it all by the highest power of x. And then we let x equal 0. So we say the limit as x approaches infinity is, okay, we have the 4 plus 1 over 0, let that x equal 0, 2 plus 3 over 0. That equals 4 plus 0 and 2 plus 0, which equals 2. So this function, as x approaches infinity, is 2. So it might be something like this, okay, like this one here. Gets closer and closer to 2 as it goes to infinity. Last one. We want to see what number this approaches as it goes to infinity. Same steps, look for the highest power of x and divide everything by that. Highest power of x here is x squared. So it's the limit as x approaches, or we can say tends to infinity, or approaches infinity, is this. So 3x squared, and we divide everything by x squared. So 3x squared divided by x squared is 3. Minus 2x divided by x squared is 2 over x. And 4 divided by x squared is 4 over x squared. Likewise on the bottom, 5x squared divided by x squared is 5, plus 4x divided by x squared is 4 over x, and minus 3 divided by x squared is minus 3 over x squared. Then let x equal 0, and we get 3 minus 2, 0, plus 4 x squared, which is 0 squared, 5 plus 4, 0 in for x, minus 3, 0 squared. That will give us 3 over 5 and minus 0, plus 0, minus 0, plus 0, which will just give us 3 over 5. Okay, so as this function approaches infinity, we get closer and closer to 3 over 5. Okay, that's it guys, thanks.